Hello, this is Geometry, Topic 7-3 over arcs and chords. Let's just go ahead and really quick refresh what a chord is. A chord is any segment who has endpoints on the circle. This is important because of some theorems that we're going to be talking about. In a circle, or congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So if the arcs are congruent, the chords are congruent. And if the chords are congruent, then the arcs are congruent. Let's go ahead and put this into practice. Which two chords are congruent? Well, AB is congruent to CD. So which two arcs are congruent? Well, that would be arc AB is congruent to arc CD. And I could have gone the other way. Well, now I need to know what the measure of these arcs are. Well, there are 360 degrees in a circle. So if I can figure out what everything else is, I can just subtract. So let's call these x. So 220 plus 20 plus 2x equals 360. Okay. So 240 plus 2x equals 360. Well, 360 minus 240 equals 120, which means that x must equal 60 when I divide by 2. So these are 60 degrees. And we actually didn't need this, we just used our formula. Set up an equation so that it equal to 360. Now, let's go ahead and look at example number 2. Well, this tells us that PS is 12 and TR is 15, and we want to figure out what QR is. Well, I know that this arc is 70, so if I can find a chord that has an arc of 70, then I'll be able to figure out what it is. Well, 60 plus 20 is 80. That's not it. But 20 plus 50 makes 70 degrees. So this arc right here is 70 degrees. So this one is also 70 degrees. So we're looking at PS. So arc PS is congruent to arc QR, which means that PS is congruent to QR. So that means if this is 12, then this is also 12. Let's go on and take a look at example number 3. Here we want to figure out what HI is. Well, I'm given a bunch of arc lengths and degrees, arc measurements, so I need to figure out the arc measurement here. Well, 113 plus 91 plus 78 equals 282. And if I do 360 minus 282, I get 78. So this is 78 degrees, which means that this arc and this arc are the same, which means that this chord and that chord are the same. So if this one is 9, that means this one is also 9. So it's just find your lengths of your chords so you can find the matching arcs, or find the matching arcs so you can find the lengths of your arcs so you can find the matching chords. Let's go ahead and take a look at another theorem. This theorem says that if a circle, in a circle, if a diameter or radius is perpendicular to a chord, then it bisects the chord and its arc. So here we're told AB intersects BC at a 90-degree angle. That's what the perpendicular means. We know that AE is 12 and all radii are 13. So we want to figure out this ED. So EAD is a radius, so it's 13. So 12 plus 1 makes 13. Well, AC, that's from the center to the edge of the circle. It's a radius, so it is 13. AB is also 13 because these are radii. Okay? Well, because this is perpendicular in our theorem, we know that these two are the same. So this is 12, this is 13. 12, 13, it's a right angle. I can use Pythagorean theorem. 12 squared plus b squared equals 13 squared. Subtract 12 squared. B squared equals, well, 13 squared minus 12 squared is 25, which means that B must equal 5. So that means that EB, that one's 5. This one is also 5. So EB is 5, EC is 5, which would make BC equal to 10, because 5 plus 5 is 10. We had to draw these two lines and then recognize that they were also radii, or radiuses. So was AD, and that allowed us to solve all the parts of the puzzle here. Let's go and move on to example number 5. Well, now here we're told, we're given a similar picture. It says if CFB, that's the major arc, is 220, we want to find everything else. Well, if CFB is 220, we want to find CB. We just do 360 minus 220. That gives us 140. So now we want to know the measure of angle CAB. Well, this was 140. So CAB, being the interior angle, is also 140. Well, BAD, because this cuts it in half due to our theorem up here, that means it also cuts the angle in half. So 140 divided by 2 is 70 degrees. So BAD, that one is 70. So the arc CD, well, it's going to be the same as this arc. It is also 70 degrees. Let's go ahead and move on to example number 6. Here we have circle A, and they tell us that SQ is 12. AT is 8, and we want to find out what AR is. Well, I know if this is 12, that means this piece is 6. I have a right triangle, so I can find my radius here. 6 squared plus 8 squared equals C squared. And 6 squared plus 8 squared is 100. So C must be 10, which happens to be our radius. So our radius equals 10. AR is a radius, so it must also be 10. Let's go ahead and move on to example number 7. We're given pretty much the same picture. We want to figure out what these are. AD, CD, and AB. Well, if this is 6, and this is a 60-degree angle, that means it's a 30, 60, 90. So our short leg would be 3, and our long leg would be 3 on the square root of 3. So AD would be 3 on the square root of 3. CD, we already said, was 3. And the measure of arc AB, well, if this is 60, That means that this is also 60, and 60 plus 60 equals 120 degrees. So we've talked about two theorems. We're going to go ahead and introduce a third theorem. And that says, in a circle or congruent circles, two chords are congruent if and only if they are equidistant from the center. So that means because this chord is the same distance as this chord, we know that these two chords are the same. So this is 8. Because this is perpendicular, this bisects. So x must also be 8. And then this chord is going to be equal to that chord because they are equidistant here. So that means that this is 8 plus 8 makes that 16. So y must also be 16. And in fact, this half is equal to those. And this half is also equal to those. Moving on to our last example, let's go ahead and start putting all of this together. In circle O, FL is 3. GO is 5. OP is 4. And we want to find HJ. Well, I'm looking at this and there's some things that I need to find out. So if this is 3, that means that this is also 3. Alright. And now we can go ahead and use Pythagorean theorem. 3 squared plus b squared equals 5 squared. If I subtract 3 squared from both sides, I get that b squared equals 5 squared minus 3 squared is 16. So b must equal 4. Okay. Use Pythagorean theorem. This is 4, which means this is also 4. Now because these are the same, that means that these chords are the same. And because these chords are the same, well, this chord is 3 plus 3, so it is 6 long. So 3 plus 3 over here makes that also 6 long, so HJ is equal to 6. Notice I also could have said, well, that's also going to be 5. If this is 5 and 4 with a right triangle, that means this also has to be 3, which means this also has to be 3. I could have worked and found some more things, but generally, just knowing that these two are equidistant, we can apply this theorem to say these chords must be congruent. And if these chords are congruent, that means that this being 6 makes this being 6. 3 different theorems to apply. We're just talking about the relationship between chords and the arcs that make them. Good luck on your assignment. Have a good day.